So the point that I'm going to try to make in my talk is that science teaching is actually a form of science communication, that teachers communicate all kinds of messages about what science is and how it gets done and what it's for. And these messages are usually implicit. In fact, they're rarely explicit. And from my perspective, as someone who has studied science learning for a really long time, that's a problem because the messages that kids get about science don't tend to help them engage with science productively outside of school. There are sort of three versions of science teaching that we can find in the world today, and they each sort of produce very different kinds of epistemic messages. And so let me just outline them here. There are really three kinds of science teaching that you see in classrooms in the United States at the moment. And they each convey very different ideas to kids about what science is and what it's for. The most common kind of science teaching we have, I'll just call typical science teaching because it's the most common and it's the sort of longest running. It's been going on for the longest time. And that's a kind of teaching where the teacher lectures at students and sort of tells them what they're supposed to learn about science. If kids do empirical work, it's generally highly scripted, and it's intended to verify concepts that the teacher has already gone over. We know not only that children don't learn a lot of science that way, they don't really learn a lot of science concepts, but what they come to understand about science as a thing that people do is that it's a collection of facts and concepts that are just accumulated in unproblematic ways, and it's not very clearly related to their everyday life. And there's not a lot of evidence that they use those ideas from their science class in that everyday life. And this kind of science teaching, let me just say, has been going on pretty steadily for a good century. So because children don't learn a lot about science from this kind of teaching, science educators and science education researchers have been interested in what we call inquiry teaching, which is an effort to guide learners through investigating scientific phenomena for themselves and sort of not exactly rediscovering the ideas that scientists have discovered, because that's quite hard, but at the very least learning those ideas in relation to problems that they're actually sort of exploring for themselves. And so this is a form of science teaching where children get more sort of authority for making some choices about not necessarily what they want to study, but how they want to investigate something. So they might be asked to design their own experiments. They are going to be asked to look at data and make sense of it. They're going to be asked to construct explanations for the data that they're looking at and to argue about competing explanations when they don't agree. We know that this kind of teaching tends to help students learn science concepts better, and we know that it helps them learn at least some scientific practices. So if you have children engaged in experimentation with some guidance over time, they get better at designing experiments. If you have them constructing and evaluating explanations over time, they get better at doing that. What we don't really know, however, is the extent to which this changes in any fundamental way how they think about what scientists do and what the role of science might be in their everyday life. The evidence that we do have on this point is that it doesn't really have much of an effect, that they see the stuff they do in school as school science and the stuff that scientists do as real science, and those two things aren't necessarily the same. And then finally, there's a third kind of science teaching that's just emerging. It's a very recent trend, and it's very much right now a research-driven trend. So this is not something that a lot of teachers in America are doing on their own. And I would call this community-oriented science. It's a way of teaching science where the science itself is framed as a tool that young people can use to pursue their own questions and their own interests. And it's a trend that's emerging out of social justice projects. So people who are interested in inclusion and equity and diversity kinds of goals. So one example, you might have students learning chemistry, say, in order to understand contaminants in the soil around their community and where that's coming from and what they might do about it. As I said, this is really new. It's one of the only forms of science teaching that's happening right now that's explicitly aimed at helping students think about what the role of science is in their everyday lives outside of school. But because it's so new, we know almost nothing about how kids see that work in relation to what professional scientists do. So the main issue then I think that we have in science education as a research endeavor is we need better ways to understand what kids learn about science as a professional endeavor from the work that they do in school. We need ways to train teachers so that less of them are teaching typical science, which is by far the most common thing, and more of them are teaching through these kinds of inquiry techniques or these community-oriented kinds of techniques. We probably need to think more carefully about what our goals for science education are overall. Is our aim that children should master the disciplines before they get to college? Or is our aim that they leave high school with an understanding of what science can do for them in their everyday lives?